Alright, so this is a test live streaming, just trying to figure out if all the components are working. So I am right now connected to the Astronomy. I have the desktop version running through the VNC here. As you can see, I also have the browser connected and also ready, because the real VNC remote connection is not that good, so I sometimes fall back to the web version. The weather in the observatory is a bit warmer than it was. These are the conditions inside the building. As you can see, this was quite chill last night. Now it's a little bit warmer. It was warmer today than it was yesterday, as a matter of fact. So this is my setup. I have the ECOS. This is the guiding tab. I'm looking at the moon right now, and let me show you the moon. So this is the camera tab where I have my camera connected. This is courtesy of the Romanian Society for Cultural Astronomy, that they own this camera. And this tab here, I can set the exposure time. So since I'm imaging the moon, the exposure time should be small, because the moon is a very bright object. And let me show you. So here it is, a beautiful crescent through the camera. This is just one frame, and you can see here the nice features of the moon. You can see the so-called seas. They're actually valleys, and you can see the mountains and the terminator here. This is the line where the shadow on the surface of the moon, as it's cast by the sun, appears. I always like this, especially when we have a crescent like this, because you can actually see the mountains, the top of the mountain peaks lit by the sunlight. The rest is in the shadows, of course. So this is an image, and could try to reduce a bit the exposure time even more, and then see if we get a better image. So this is it. Of course, could go to a live video, but I'm not going to do that because I tried it before and the memory gets eaten completely on the Raspberry Pi, and basically freezes everything. So I am not doing this at this point. So let's take a couple of images, just one for the test. So let's save them, documents, sessions, and I will create a session for the night. So I'll We are on the 14th of January 24. And I am imaging the moon. Right, let's take a, yeah, this is it. So there it is, nice image. This was captured. This is the moon tonight. All right, so let's see what else we can look at this evening. In the meantime, I just want to double check that I have everything is still connected and I'm live streaming. So yeah, all good. Let's go back to the Pi. So this is running in my observatory actually. And we are here. You can see here it's the moon and we have Saturn. Actually, let's go and see Saturn. So now we should be around Saturn. The alignment and could be a bit faulty at this point. It's not fully fixed. So I'm just gonna see if we have Saturn here. So I'm just gonna capture quickly with my guide scope. So this is Saturn, as you can see. And let's take an image of Saturn. Let's preview first, see what we've got. Because this little dot here could be Saturn. Yeah, definitely Saturn here. You can see the rings. So this is a nice view of Saturn and the rings. They're perpendicular as is seen in this image. This is not a camera for solar system objects. This is a deep space camera for deep sky objects. So this is why probably Saturn is not like what you are used to. But nonetheless, you can see the structure of the rings. I like it, so I will try to increase the exposure times a bit. Let's see if we increase it, if we get anything better. Yep, too much. You can see it's overexposed. We can still see the rings, but the planet itself is overexposed. So I'm going to bring it back to 009 and try it again. Okay, let's zoom in here. Yeah, still overexposed. We need to go down even more. Let's say a 5. I'm just experimenting here. This is the first time I'm using this setup, so don't know the exact numbers for these. Yeah, much better, but still overexposed. So we still need to reduce this even further. So let's bring it to 001. And let's see how it looks right now. You can see in the field of view, how small the planet is compared to the area the camera sensor is able to see. I don't like it. It's underexposed actually at this point. So I'm just gonna bring it up a bit to 003. And let's see. So this is Saturn again. Let's see. Yeah. No, it's not bad. All right. So we did have a quick look at Saturn just for testing purposes. We have Jupiter as well. So these two here are about to set. So this is why I chose them first. And we have Neptune as well, Jupiter. Let's go to Jupiter and see if we can see any of its 4 major moons named after Galileo Galilei. Okay, so we are going to Jupiter at this point. It is going somewhere. It is going to Jupiter. I think it's doing a meridian flip at this point because Jupiter is on the other side of the meridian. So the telescope is probably doing what's called a meridian flip. And now it's going following the declination lines. It's going straight for Jupiter. All right, so we have arrived at Jupiter. So let's see what we've got. As you can see, the interface is not cooperating, but this is due to the fact that it's running on a Pi, and I'm using BNC to connect, which makes things worse. And sometimes you see this strange loss of resolution here, which is due to the bad connection over the VNC. So let's see, let's capture Jupiter and see if Jupiter is on the image or not. And not sure if it captured or not. All right. Yeah, this is one of the pitfalls of remote connecting to a board which doesn't have enough resources to do all of this. All right, so and the bad thing is that if you start clicking buttons before waiting to see if your previous command has worked or not, you just end up killing everything, and then the VNC connection basically drops. And yeah, I am somewhere near Jupiter, which is a bit. You can see here this low resolution white spot This is probably Jupiter resting somewhere here on the edge of the guiding camera's sensor. And since I don't have a clear image of this, it's really hard to see if there are any other stars, because since it's not pointing directly at Jupiter. Now what I normally do is I go to this tab here, which is the alignment tab, and I align using the astrometry solver based on the stars it sees. It looks for the patterns and it basically aligns. So if you leave it enough time, usually gets better, but it's annoying. It actually worked quite well. Before testing this live stream, I was playing with the moon a bit, focusing, and it was quite all right. There weren't any major issues. Okay, so what I can do at this point is go here in the main telescope camera, this tab. I just clicked on it, and I'm waiting for it to respond. All right, so here it is, and I will try to, let's increase the exposure time a bit. All right, so perhaps a bit too much, but anyways, let's capture a preview and see. Well, there it is. There you have Jupiter. And given it's a low resolution image, it works in our favor because it brings out only the key details, and you can actually see two of its satellites, which is quite nice. I clicked too many times, and this will not work in my favor. Yeah, here it is. There are actually four. You can see four of the satellites here. It actually looks better this is not the real image. This is just the low resolution image coming from the Raspberry Pi in the observatory. But it actually captures all of the four satellites that Jupiter has. So you see you've got 1, 2, 3, 4. So you have Io, Callisto, Ganymede, and Europa. And this one in the middle is Jupiter, of course. So you've got all these four satellites here, which are nicely captured, and they're also visible in the full resolution image. And there it is. Basically, this means that the connection dropped for a second, and it's back now. So you can see now nice and smooth the four main satellites of Jupiter, and I will remove this, and I will add a new job with these parameters, and I will go in Documents and Sessions today, and I'll create a new folder, and I'll call it Jupiter, and I'll say, and I will take a picture of Jupiter This is not the way it's done. I'm just taking one for, for the fun of it. Usually you don't use this kind of camera for planetary observations, and you take a movie and you basically post-process the image to get those nice images. But this is how it looks basically when you see them like this. All right, let's take the image. Okie dokie. So we've got a nice, very nice image of Jupiter with its 4 Galilean satellites. All right, good. So let's just switching tabs here. All right, so let's try and go and see something else. Now it's winter, and in winter I would really love to see M42 or maybe the Andromeda Galaxy here, but I'll go to M42, the Orion Nebula. So we are going there. And let's see. Well, since we are around stars, we need exposures over 1 second. Let's use a 3 second to capture something and to see what we are having in the guide scope. So you can see here, you can actually see the Orion Nebula at this point through the guide scope. So this is the Orion Nebula through the guide scope. And I will capture and solve and try to improve the accuracy of the go-to and the alignment. So basically slew to target, capture and solve, and I'm taking a few images here. It says no solution found. Let's try again. Yeah, not that good, was it? It was a lot of arc seconds in error. 184 arc seconds in error, so it's getting better. It's taking about 4 images just to double check. 9 arc seconds. So this is actually very, very good. And I will try to take an image with the main camera through the telescope. Let's say 10 seconds. And I'll just preview just to see what's happening, what we actually have in the camera. Yeah, and it seems we've got some clouds. It is a bit cloudy, isn't it? We've got some clouds, but otherwise these are the stars, and I'm not guiding. I should be guiding, shouldn't I? So I will click on guide, and you'll see that it automatically selects the best star, and then it will select other points that it uses for guiding, and basically now we are guiding, and this makes the telescope fixed on that position, so it really enables us to take long exposures on our images without seeing any sorts of drifting and trails in the stars. They look nice, sharp, as they should be. So this is done through the guiding scope, the 120 mm. And now I'm going to take a 10-second image of the same area with the main scope. You can see here the countdown, it's exposing for 10 seconds. And there it is. Yeah. And you can see it's way better. I mean, if you look at the stars, they're better than before, and they even have these spikes here. But we are not anywhere near the M42, because I didn't actually tell it to go to M42. I told it to go somewhere else, to some star in the neighborhood. Let's have a look a bit at the statistics. So the guiding works. It's green. We've got the alignment, which is green, and the capturing. It's always good to have a look at these. The mount looks excellent, all green. There were some issues with the alignment, but not anymore. These red ones are basically from the previous alignment that we had. All right, so I really do want to see M42, so I'm not gonna go away from this region until I actually get to see M42. So I will, let's see. Yeah, we are not actually, as you see here, this is where we are, and M42 is here, I believe. What I'll do, I'll just move the scope a bit here. So yep, and then let's see what we've got. All right, so this is the nebula, the M42, and I will tell it to guide, but not that much. I don't want exposures of 2 seconds, because you still see the trails, because it's too much time between exposures. So you really would like short exposures, short frequent exposures, instead of long and less frequent exposures when you're doing this. So there it is. So we've got some let's see. Yeah, we've got some alignments. Good. So 10 seconds on the on Orion Nebula. Let's see. These nebulas really look awesome, even without processing and black and white. This is a black and white image, by the way. It's a black and white camera, but you can get color images out of it if you want. because basically an image is comprised of three individual channels, red, green, and blue. So you can take an image for red, you can take an image for green, you can take an image for blue, and then you put all of them together. So you mix the three, and then you get the color image. I think I forgot to click on this. So I'm just gonna, yeah. Oh, nice. Nice, nice, nice. Look at this. And you've got the clouds. It even makes it, it's even nicer than normally, because you've got, these are clouds here. And I will save this one. I love this one. I'll call it M42. And I'm just gonna name it, I don't know, M42, and I can save a PNG or fits. I'm gonna save a fits. All right. Let's increase it even more. Let's give it a 30-second. Is it still guiding? Let's let him guide a bit. All right. As you can see, there is a small discrepancy, misalignment between my guide scope, which has the M42 centered, and the actual telescope, which has M42 towards the bottom of the image. So I'll need to work a bit on aligning the two, but nonetheless, both are in focus. So let's take a 30 image shot of M42 and see how it looks. Oops. Oh, it was aborted. Let's take it again. You could do a tour of the whole night sky, and I'm actually planning on doing the Messier marathon, which takes you through all Messier's. Charles Messier was a French astronomer which cataloged about 110 objects, deep sky objects, and I'm planning on doing this to actually see all the objects live streamed in images like this. This is really nice. I mean, look at this. It's you can see the nebulosity, you can see the dust, the gases, and this is a dark nebula here, and this is an emission nebula, and these are very young stars being born here, and you can see the spikes, the diffraction disks, and all the other stars here, and you can see another nebula here, a dark nebula as well. And of course you can see lots of clouds. These are all clouds, and it's gonna get cloudy, so I'm not sure how long I can still play around here with this. Let's push it to the limit, and let's give it a 60-second image and see what's happening. All right, well, this M42, the Great Orion Nebula. We still have 30 seconds of exposure time. It looked absolutely gorgeous on 30 seconds, and then I'm pushing it to 60, and then I'm going to go to M31, the Andromeda Galaxy. previously known as a nebula, before Edwin Hubble discovered that in fact it's a galaxy, it's an object outside of our own galaxy. All right, so nice. Look here. You can see it's even better. These nebulosities here, they are amazing. Look at this. It's really. You can see the dark nebulas, and you can see the mission nebulas here, and the young stars, and here again. So it really looks amazing. All right, so let's save it. And I'm curious to see if how close we are to the actual M42 target. So I'm going to capture and solve this again and see what's happening. And we are within 40 arc seconds of the target. So this is not bad, actually. It's not bad, but it usually tries to bring it within 20 arc seconds. So now we are straight on with the guide scope. But what I can do, I can center it using the main camera as well. So I can also, because they are misaligned a bit, so I can align it using the main camera. So let's do just that and see that we have the Orion Nebula in the center of the image. Ooh, that's a big one. As you can see, it's down here, so it's solver failed. Let's try it again. I do know why it fails. It's because my database is configured to work with a small camera, not this one. So my star catalog, the database I'm using for astrometry, is different. It's not what's needed for this. So if I go to options, for instance, and I go to index files, I see here that there are lots of them missing, so I'll need to download all of these to make it work. So these are all the required ones. So I don't have the required ones, basically. See these ones here to make it work with the big one. I'm not going to do it right now because it will kill the bandwidth I have with the remote server, because it gets all of them on the remote server. So I'm not going to do that now. I don't want to. So instead of that, let's go to M31, the Andromeda Galaxy, which is, you can see here that we got this is M33, and we've got the big galaxy here. This is M31. So I am Andromeda. No. Yeah. Go to, and you'll see the telescope. Where is the telescope? It disappeared. Ah, there it is. It's going somewhere. It does these things, especially when it's showing here. I'm not sure why it goes outside of the um, planisphere, but it's going where it should be. Hopefully it didn't hit anything with on its way there. No cables or something in the observatory. I'm still not sure how all works in terms of cables and that, if they're loose, if they get unplugged or stuck somewhere when the telescope is moving. Still need to double check that, but it's quite cold now, so we've got, it's getting colder, 4 degrees. Right, so Andromeda. Let's see where we are first. Yep, this is Andromeda here. This fuzzy patch of light. This is the galaxy Andromeda. So I will tell it to guide a bit. Right. And let's take some images of Andromeda. 15 seconds should suffice. It's really nice to be inside when it's so cold outside. You just sit in front of your laptop and you get these cool images. And there it is, Andromeda Galaxy. This is really nice, but the tracking is awful. Look at these star trails here. But you have Andromeda and you have the satellite galaxy of Andromeda here as well. And you can see the disk and the dust in the disk. It's a spiral galaxy, just like the Milky Way. All right, so this is we are guiding, which is good. So let's take another shot at Andromeda. Oh yeah, much better, isn't it? It's way better at this point. You see the satellite galaxy and you see another galaxy here. I don't remember their names. And you can see the disk spiral structure and the dust clouds here in the spirals, and you can see some details here as well. And it's not bad for a 15 second exposure of this object. It's not bad at all. But nonetheless, I would like to All right. Okay. Yeah, I cannot align while it's capturing, it's guiding. But it is fine. Let's try and take a 60-second exposure of Andromeda. Let's see how it looks like. Oops. Yeah, failed, but I'm restarting it. It's actually going quite well. There are a few tweaks here and there. The interface, the VNC is back up and running, really nice. Didn't have any issues in the past 20 minutes or so. I'm gonna take this one and trying to figure out what else we can see. Nice. It's really nice. We'll decide in a second. So M31, just call it M31 and that's it, basically. Let's try to do a live video and see how it looks on the live video. So this is a live video at 1 frame per second. Doesn't show much, does it? Let's make it a 3 frames per second. You actually see here the CPU usage going way up when I started this one. At 3 seconds, you can start seeing the galaxy core here. But the frame rate is 0.3 seconds. So this basically means that this is refreshed every 3 seconds. It's not really good for live streaming, but it doesn't matter. So let's see what we've got on the night sky. So we do have here some interesting objects. M27, it's too low. I'm not going to go there. M57, too low. I'm not going to go. We've got Betelgeuse. We've got Taurus with M45. We've got Ursa Majoris with the cigar M81, M82 galaxy, so it's a nice spiral and elliptical. Let's see how M45 looks like. So we've got M45, the Pleiades here. So we should be able to see them nice and so you can actually see here the image. So you've got in this big box here, the white one is the view of the camera of the main scope, and then the yellow one is the view of the small guiding scope. So yeah, why not? What do we have here? Let's see what stars are these. Alcyone, right? This is a good start to go to. Let's go there. And it's going. It's always fascinating to watch this guy going somewhere in the night sky. It's probably did. No, there was no need for a meridian flip, was there? Because they're not. Anyways, it doesn't matter. All right, so we should be right on spot. So let's capture and look here. This is the cluster of stars. So we are near the Pleiades, not quite on target, but near. So what I'll do now is capture and solve here just to double check that all is good. Yeah, it's way off. See here. So now it's doing a second one. You see, this is the Pleiades cluster. You can actually see it here. See the seven sisters. 1, 2, 3, 4, 5, 6, and 7. And now the target is on track, and I will tell it to guide. It's looking for an autostar to guide. All is going well. So let's take a 10-second exposure first, just to double check that all is good. Nice. So many stars here. They look absolutely fantastic. All right, so what I will do now, I'll go to mount control, and I will do something because I have that misalignment between the guide scope and the mount. The quickest way, and I don't have the stars for the astrometry for the main camera. The quickest workaround is to basically select the primary scope, and if I capture it, you can see it here. And obviously I would like to let's bring it down to 1 second and loop. When it refreshes every 1 second, and I will move the scope. You can see the stars running away. Nope, the other way around. Oh, too much. Yeah, we've got some stars back. And we also have a satellite here. This is one of the satellites. See, it's going in the it's not going in the same direction with all the other stars, which means that it's definitely not a star. Yeah, I don't really like this. What happened at this point? Okay, so let's see if, yeah, so it's basically just trying to control the telescope and capturing images from the telescope remotely from inside the home. The connection is a bit slow at this point again through the VNC. And I will stop the capturing of images. This is probably one of the things that is impacting the connection. So let's go back to the interface. So we were here somewhere. And I'm trying to focus on the we've got Atlas, Alcyone, Melope, Maya. These are all stars in the Pleiades. We'll go to Atlas at this point. There is a delay between what I'm doing and what's happening on the remote server. Pleione. Let's go to Atlas. Yep, this is it. And I will go to, and we should see the telescope centering on Atlas right now. And that's it. I'll start ECOS and let's capture something and see where we are. Yep. And let's guide. It will select a star automatically and then it will guide everything. Okay. So now let's take an image. 10 seconds looks good. Let's take an image of the M45, the open star cluster. So we've seen a nebula, we've seen a galaxy. If you missed it, you'll see it. And now we are looking at the M45 Pleiades star cluster here. Let's try to capture and align again. I like doing this because it allows you to, this is Atlas, this one. It's 58 arc seconds away from the center of the image. So it tries to focus, to put it straight in the middle of the image, basically. And there it is. Good. So I'm going back to tracking, guiding, and click guide, and let it guide. And going back to the main imager, and let's take a preview for 10 seconds of Atlas, which is part of the Pleiades star cluster. Yep, you can see it here. This is Atlas, and this is this one here. It also has a name, but I don't remember the name of that. So let's try to see what we see from the main. This is a live view from the main telescope, and I will, if you go here on the telescope, mount control, and then back to guiding. You never know which way to go, and I'm just gonna click this, see what happens. No, wrong way. Yeah, it's going up, which is good. Trying to bring the Pleiades star cluster into focus, basically. not pushing it too much. Because it will stress the connection and the pi as well, and you will see a loss in the resolution. All right, so now we've got Pleiades in the main camera. Let's bring it up a bit more. Okay, so I can close this one. And if I want to use the main camera, I need to switch back to the guiding, and I'll guide with this, and it will use another star. We'll see an image in a second. This is the image with the from the guide scope. Okay, so let's go back here and take a beautiful image of the Pleiades star cluster. A bit difficult till you get used to it, but once you get used to it, it's fun. It allows you to see some live streams. Wow, look here. We see the nebula around the star cluster. So these are young stars. I don't think the dinosaurs saw this star cluster. If I remember correctly, I was reading at one point that these are younger than they are born after the dinosaurs disappeared from the planet. If I remember correctly, my memory could be misleading. Let's take a 60-second snapshot of this, and you'll see the nebulosity. So these stars actually go through a reflection nebula, which is bluish. And in images on the internet, you actually see this as you see the stars around a fuzzy bluish nebulosity. This is it's not part of the cluster, but the cluster goes through that region of space which has all these gases which look blue. So 16 seconds, still 16 seconds, and then we'll see a nice image of the Pleiades star cluster. So again, this is a test session. I'm just testing the equipment at this point, trying to see if anything useful comes out of it. So here it is. This is the Pleiades star cluster, and you can see the nebulosity. So this patches here, the white patches are actually blue when you are seeing a color image, and this is the nebulosity. So I'm just going to save this in my sessions, create a new folder for M45. I'm going to call it no, not here, inside the folder, M45, and I'm going to save it. You can actually have shorter images, like 5 seconds in exposure times, and these still look nice. They don't show as that much detail as an image with 60 seconds of exposure, but you do still see the stars and all that. So what I will do now at the end of the session, I will park the scope. So if I click park, it will go to its resting position, and then I can close the roll-up to protect it during the night. So I will park it, and you will actually see it going to its parking position, pointing north. So it should park here towards the north geographic. Yep, I think it's parked. Let's double check. Yep, it's parked, and it's pointing to a azimuth of 4 degrees and altitude of 0. So roughly towards the North Pole. Second thing that I usually do at this point is I disconnect all my devices and I stop ECOS, and that's pretty much it. Thanks for watching, and I hope you enjoyed it and you've seen some nice things. We've seen a few objects. We've tested the equipment, which is the important thing, because I will be doing live sessions of the night sky, and I will be doing them perhaps weekly if the weather allows. I will choose some objects for about an hour, and I will discuss about these objects, and we'll see some images of these objects, and you can ask me questions. In the meantime, enjoy and take care. Don't forget to like, subscribe, and stay tuned for future videos. See you guys next time.